Welcome to a new video in my Weidmüller Automation Controller series, and today I'm going to talk about OPC Server. And without going into too much details about SCADA systems and also OPC servers, which could be a video on itself, I just want to get to the end result straight away. We have teamed up with a local company here in Hungary, which is called the webSCADA, and they have a SCADA system which can draw data from OPC servers. And the OPC server in this case is going to be our Weidmüller Automation Controller. So what we have in the SCADA system is a simulation of a pumping station or a lift station, where, as you can see, there is a reservoir which is being filled by water, and we have a couple of float switches, and these float switches operate one of the pumps that are going to pump this water into, for example, a higher location. And the reason I'm saying simulation, because we don't have the exact setup with the, the float switches and the pump. Actually, I'm using a Node-RED flow to simulate how this lift station works. So I'm simulating inflows and pumps being turned on and outflows that are reducing the water level. But the main thing is that this Node-RED flow is going to publish this data into global variables, and I'm going to use the OPC server integration on the Weidmüller Automation Controller to publish this data. And webSCADA reads these values from the OPC server, and it's going to display it in this SCADA visualization page that you can see here. I said I'm not going to go into the details, but just in a summary, so SCADA is a supervisory control and data acquisition system, and this is what had been used from the past to monitor industrial processes. So the idea is that you have various control devices, PLCs, that control an industrial process, let's say in this case a pump station. And then the data is fed into a central system where it can be monitored. And of course, this central system would probably monitor multiple of these stations, many different PLCs, and that's how you can oversee an entire network or an industrial process. And these supervisory systems can be something which is specific to the vendor. So if you go for a specific vendor PLCs, you probably be able to use their supervisory system. But in case if you have a system from different vendors that they are using different communication protocols, an OPC communication platform was created, meaning that if your devices support the OPC platform, let's say they operate as an OPC server, then OPC clients, for example, SCADA advisory systems, would be able to connect all of your devices and be able to integrate them into a single platform. As I said in the beginning of the video, we choose webSCADA to use this demo with, and they are a Hungarian company that we could work with. And this program is primarily made for the local market, hence sometimes you see Hungarian names and letters in the translation, and for example, the date and the time format is Hungarian. As I said, there are many similar solutions available, and they are all going to be somewhat similar. As I said, it's all about communicating with devices and then somehow displaying this data visually and in charts and in some sort of reports. The main objective of this video is to talk about the integration, but just to have a full picture, I also want to talk about the overall design. So as I said, what we are trying to simulate here is a lift station. So there is a well or some sort of water tank where the water is being filled, or there is an inflow, and we have two pumps, and when the water level reaches certain levels, then one of the pump is going to turn on, and the system monitors how long each of the pump is running, how many times it has been switched off. It's as you can see here, it shows the operating hours. I mean, of course, for the sake of this simulation and the fact that we don't have to wait for a long time, it is actually counting seconds at the moment. As you can see, if the water level drops below the last flow switch, which is at the moment set to 10%, then the pump is going to turn off, and then the water level again rises because there is a constant inflow, and once it reaches the first float switch, then the pump, which has the lower operating hours, is going to turn on. So ideally, these two pumps are going to alternate just to balance out the usage. And if there is such a high inflow that one of the pump is not able to pump the water, then the water level is going to reach the second flow switch, and then the second pump will start as well. So this is a fairly simple simulation, and as I said, because we don't have the exact physical hardware, actually created this flow in Node-RED, and I'm going to make this flow available. So if you are interested how I did it, you can just follow the flow. And unlike with most of my other flows where I do a little bit of JavaScript programming here and there, I try to do this I try to do this purely with standard Node-RED nodes. So as you can see, it's basically inject nodes and mostly change nodes and switch nodes. And there are a few function nodes, but they are just to, print the values here on the screen, so I can see what the code is doing. And of course, most of the things that this flow is doing is stored in various flow variables. So I have the level set for each of the float switch when they turn the pumps on and off. I have a simulated inflow value and an outflow value, and the outflow value is based on whether one or two of the pumps are running, and of course there is a water tank level. And the heart of the code is pretty much two inject node. First of all, there is this part of the flow which executes every second, and it calculates a delta in the inflow. So it varies from time to time. As you can see, it's 299 at the moment. And there is another inject node which again fires every second, and that calculates the level change. So it calculates what is the inflow, adds it to the level, and then also checks if the pump is running. Then of course it subtracts the outflow from the level, and once the update is done, it also checks the float switch, and then based on which float switch is reached, then it's either going to turn one of the pump on or turn both of the pumps on, if that is required. As you can see, the tank is filling up now, and if I'm going to add, well, I'm just going to click on this one, which adds 7,000 to the water level. So the tank is full now, and both of the pump has turned on, just to reduce the water level much more quickly. I've created this flow even before I had the integration, so everything is stored in flow variable. Then at the end, I just created this update node, which again executes every single second, and then it writes the flow variables into various global variables. So I've created a list of global variables, and these global variables are in Hungarian because we reused an existing example, but they actually correspond to one of the variables that you see on the flow. Again, the only difference is that here in the flow, I simulated the tank level to between 0 and 10,000, and here on the SCADA simulation we are actually using percentages, so obviously the values have been rescaled. And with this, the global variables are getting updated every second. And once we have that, we can turn our attention to the OPC UA server. And this is something that we haven't used just yet. So I'm going to open this application, and that's where we are going to create our OPC UA integration. So there are a couple of things we can do here on the main screen, and there are two important fields that we need to maintain. First, we have a port number, and 4840 is the default port number. Of course, you can change that if you want to. And the main switch up here is going to turn on the OPC UA server. It makes the Weidmüller Automation Controller as an OPC UA server, and the SCADA system are the OPC clients that connect to the server. Of course, one SCADA system would connect to multiple servers when you have multiple PLCs. And once we have the server up and running, actually before we have the server up and running, we can specify which are the variables that we want to publish into these servers. And these are the variables that are going to be available for the OPC clients. And well, for this example, I've enabled, or I published all of my global variables, but of course you don't have to do all of them. In my case, the Weidmüller Automation Controller is running in the same network as the SCADA visualization client. So there is no need to set up any additional data security, but as you can see, there are various options available if you need to do that. If the automation controller is connected to the OPC client via the open internet, you probably want to set up some sort of security. So you have a couple of different layers of security. First of all, you can disable the anonymous access, and then your clients will require a user ID and a password authentication in order to log into the automation controller or get data from the automation controller. So you can disable the anonymous access, and here you can change the user ID and the password. Only the password. The user ID is fixed to OPC-UA-user. And the other thing you can do is you can also install client certificates. So again, these are to set up trusted communication between the OPC server and the OPC clients. And I also wanted to show you how you can test the OPC UA server with a test client before you would connect it to any SCADA system. I've jumped from the demo automation controller, which is running the simulation, to my own automation controller, which is actually right besides me. I have also enabled the OPC UA server on the same port, and I have a couple of variables that are set to publish. So this is running at the moment, and I can use an OPC UA test client. There are a few of them that are available for free to download from the internet. I'm using integrations object OPC UA client. The first thing you need to do is click on connect, and you have to provide the endpoint. And in my case, it is opc.tcp:// the IP of your automation controller and the port that you specified on the OPC UA client configuration. And you click apply, and then it connects to your OPC server. And if I start opening up the different folders here, so if I open up objects, device set, controller, and the actual application, so you can see like stuff like the manufacturer and various other bits and pieces that the Weidmüller Automation Controller provides by default. You can drag these values in, and then the clients start getting this data from the server. So you can see this is, manufactured by the Weidmüller group, and what is the hardware revision number. And then once you open up the app, that's where you can see the various variables. And these are the variables that I have opened or published in my OPC server. So you can see the various out variables. So if I go back to my client, let's bring out2 over, and it's false. And let me click on my button. I think this is the one which makes it true. And yeah, now it is true. So this is how you can test your OPC UA server. And as I said, there are many SCADA clients available, and therefore I'm not going to spend an awful lot of time talking about the webSCADA, because the functionality that you are getting here are probably going to be somewhat different in other SCADA system, but there are going to be a lot of similarities as well. As you can see, with industrial controls, we do like a lot of visualization. So here you can see the water is being filled on the tank. You have various icons that are changed to visually indicate the state of various devices. For example, whether these float switches are hanging or floating in the water, whether the pump is running, and of course you are getting data that are being constantly updated. Here we also have a chart which is going to show us the pump status, or actually I think it is, and because we have an awful lot of data points, it is actually going to be really dense. I could play around with the values, so the tank is being filled up much more slowly or being emptied much more slowly, but I want it to be a little bit more active when I do the presentation. Of course, this is not really a good indication of how it would work in the real life. And of course, the communication is not only one way. We do have a couple of examples here. So for example, in the settings, okay, some of this is Hungarian, but I can change the values when the various float switch levels are activated. So now I place the first switch to 80%. So it means that it's going to allow the tank to fill up all the way to 80% before the first pump is going to turn on. And I can also change the behavior of the pump. So at the moment, the pumps are set up to auto, so they automatically start and stop whenever the level is reached or the tank is emptied. But you can set them to, let's say, to on or shut down. So if one of them requires a maintenance, you can shut it down from the SCADA system, and the code would then just use the other pump to basically do the pumping. And as I said, on the right side of the screen, we are seeing a chart which is going to show us the actual tank level. And here on the bottom of the chart, you can also see an indication when pump 1 or pump 2 was actually working and turned on. And since this is a monitoring system, you also have a lot of other features as well. Besides the visual representation, you also have an event log, which are going to show the various events when, for example, the float switches were floating or actually turned off or hanging in this case, or whether the pump started operating or stopped operating. And when you want to understand how the system works, you can also create custom charts where you put various variables on the screen, probably not the pump power because that's going to be a very high one. So I don't know, maybe the float switches, and how it translates to the water level. And again, I would need to zoom in quite a bit. So here you can see that the float switch triggers, and that turns on the pump, and that reduces the water level. Then at the lower point it turns off, then the tank starts filling up again. And in this lift station, the key metrics that maintenance people are looking at is the operating hours and the number of switches, and that's being tracked also by the SCADA system. So we can see how many times each of the pump has been switched on and what is the total operating hours. And finally, we can also keep track of the communication with the OPC server. We can see that the communication is working. We are reading and also writing data to the OPC server from time to time, and we don't have any red light in the communication. The functionality that you will get in the SCADA system is going to vary from one vendor to another. And this concludes my video on the OPC UA server integration with the Weidmüller Automation Controller. If you have any questions, ask them in the comment sections below. You will find all necessary links in the video description. But that would be all for today. Thanks for watching, and hopefully see you in the next video.